Okay, this is part 2 of the video lecture for Math 140 for Tuesday, April 21st. And the topic today is the ambiguous case of the law of signs. And what I'm going to do now is consider an example problem where we'll have to determine which case we're in and try to solve our triangle. The first part of this example, part A, let's consider the following triangle, okay? Now the first question here is this triangle even possible? And we talked about in the previous part of this video, for this triangle to be possible, C has to be long enough that it can actually come down and at least just touch side A. Okay, so what I want to do is consider a right triangle. Let's consider the following right triangle. Same angle of 22 degrees and the same side length of 30. This is a right triangle, and this is side length C. Let's try to figure out how long C has to be to just come down and touch side A. And so the way we do that is we can use the sine function, the sine of 22 degrees. Okay, that equals C over 30. Okay, and now we can solve for C. So C will equal 30 times sine of 22 degrees. And if you calculate this, this comes out to 11.2. So this side length C has to be at least 11.2 long in order to come down and at least create some kind of triangle by touching side A. Well, since C is 10, which is less than 11.2, that means that this triangle does not exist. So this triangle does not exist. This is not a possible triangle. Okay, let's consider another part of this problem. So I'm going to draw another triangle that's very similar to this triangle, except for one difference. Okay, in this new triangle, let me draw the triangle here. This is part B. Okay, and here we have, this is side length A. We have this go up. This is a 22 degree angle. We have side length C, okay, and this equals 40. In this case, C is equal to 40. B is still 30. And this angle is 22 degrees. This is angle C, side A, side B. This is angle B, and C is equal to 40. Now let's look at this triangle. Is this triangle possible? Well, we found in the last problem that side length C has to be at least 11.2 to come down and be able to touch side A to create some kind of triangle. Well, clearly C is greater than 11.2, so we're going to get some kind of triangle. But now the question is, which case are we in? And the way to understand that is, if you look at C here, C equals 40 is greater than B equals 30. Okay? C is greater than side B. What that means is we're in case 4. This means we're in case 4 that I discussed in the last video. And what that means is we only have one solution. And the reason is, I have this side length C of 40. I can't create a triangle where angle B is obtuse, because when I try to bring side length C in here, since C is equal to 40, and this is obviously not to scale, when C is equal to 40, I can't fit it in here because this is 30, and this is longer, and it won't simply fit in there. So the only possibility I have is an acute angle of B, and let me actually redraw this to the proper scale. Okay, so I'm going to extend this side here, make it very long, and then we're going to extend this down like this. This is side C is equal to 40. This is angle B, right? And so this is what we have. We have only one possible triangle. And I want to solve for the sides and angles of this triangle. How do I do that? Well, I need to use the law of sines. Now this pair, I know both the side length and the angle, so I'm going to start with that. I can use the law of sines. Sine of 22 degrees divided by 40, okay, equals, let's take angle B. Sine of angle B divided by the length of B, which is 30. So now I have an equation with one unknown, the angle B. I want to solve for the angle B. If I do that, I get the sine of the angle B equals 30 times sine of 22 degrees divided by 40, okay? And this comes out to, if you guys calculate this, let's calculate this. 22 sine times 30 equals that, divided by 40 equals 0.280, 81 actually. That's the sine of the angle B. But I want angle B, so what I do is I take the inverse sine, and B will be the inverse sine of 0.28, okay? And if you do that, you get 16.3 degrees. So now I know angle B is 16.3 degrees. Okay, and that's good to know. Now knowing this, I can actually figure out angle A, because I know the angles have to add to 180. And so angle A will equal 180 minus 22 degrees minus 16.3 degrees. And this, if you put this in your calculator, this comes out to 141.7 degrees. So now I know angle A is 141.7 degrees. Now the only thing I don't know is side length A, and I have to use the law of sines again to do that. So I can do this way: A over the sine of 141.7 degrees. That equals, pick your other favorite pair, that equals C, which is 40, divided by the sine of 22 degrees, okay? If we solve this for A, that means A equals 40 times the sine of 141.7 divided by the sine of 22. And if you plug that in your calculator, you should get 66.2. So this is now the length of side A is 66.2, okay? And we've successfully solved our triangle. This is a case 4 situation. Let's check the reasonableness of our answers. You know, B looks like it should be a pretty narrow angle, which it is. A looks like it should be pretty obtuse, which it is. And then this side A looks like it should be longer than either side B or C, which in fact is true. So these answers seem to make sense to us. Let's do one more part of this problem. So I want to draw for you guys one other triangle up here. Okay, our third case here, we'll label this part C. Okay, part C. And this third case is, what if we have this triangle? This is side A. This is 22 degrees. B equals 30. 22 degrees. This is angle C. This is angle B. This is C equals 20. Okay, this is angle A. Okay, what if we have this triangle? Now, we already know this angle and this side are the same as all the other parts of this problem. We already know that this is a possible triangle because C equals 20 is greater than the 11.2 minimum needed to come down and touch side A. So this is a possible triangle, but is this a right triangle? Well, we know it's not going to be a right triangle because for it to be right, C would have to be exactly equal to that minimum of 11.2. So we know this is not a right triangle. So this isn't case 1 or case 2. And in fact, C here is between, so 11.2 is our minimum amount needed to form a triangle. And C is between that at 20, but C is less than B equals 30. Okay, so C is sandwiched between the minimum needed for a right triangle and side length B. So in this case, we're definitely in a case 3 scenario. And so here we have an ambiguous case. This is ambiguous. Okay, because there's 2 possible triangles. So let's consider those 2 possible triangles. The first triangle I'm going to consider is the case where B is acute. Okay, and what I'm going to do is just use the triangle I already have here. Okay, so this is the first ambiguous possibility. And B is acute, and so I'll just use this triangle as my diagram. And I want to solve this triangle. The way I'm going to do this is use the law of sines. So I will write sine of 22 degrees over C, which equals 20, equals the sine of B divided by the length of B, which is 30. Now this leads to the case where sine of B is equal to 30 times sine of 22 divided by 20. And this comes out to, if you guys calculate this, let's actually calculate this right now. 22 sine times 30 divided by 20 is 0.562. But we want angle B, so angle B will be the inverse sine of 0.562. And if you guys do that, if we do the inverse sine of this, this should come out to 34.2 degrees. Okay. So now I know angle B is 34.2 degrees, which seems to make sense based on the diagram. Okay, let's solve the rest of this triangle. Now I can solve angle A because the angles add to 180. So angle A equals 180 minus 22 degrees minus 34.2. And if you guys calculate this, this means that angle A is equal to 123.8. If I did the math of this correctly, 123.8 degrees. That's angle A. And then the final part of this is to get side length A. I'm going to use the law of sines again. So A over sine of 123.8 equals, pick your other favorite pair. We'll go with sine, C equals 20 over angle C, which is sine of 22 degrees. This means that A is equal to 20 times sine of 123.8 divided by sine of 22. And if you calculate this, we get 44.3 for the value of side length A. And that seems to make sense based on the diagram. Now keep in mind, we have another possibility here. Okay, we have another possibility, and this is still part C because there's two solutions to case 3. And what I'm going to do, so to remind myself of it, I'm going to write down what I found for angle B. We found in this part angle B equals 34.2 degrees. Okay, I'm going to erase this, and we're going to do the other solution to this ambiguous case. Okay, so in this case, we have a triangle that looks like this. The same thing where we have this side is side A. Let me make sure I'm consistent with my labels. This is 22 degrees. Okay, and then this will look like this. This will extend like this. And then we're going to have something like this, where this is 30. This is B equals 30. This is angle C. This is angle B. This is angle A, right? And we know side length C is 20. Okay, this is the other possibility, the other solution for the ambiguous case 3. And in this case, we have an obtuse angle B. So this is the case where angle B is obtuse. And we want to solve this triangle. Now keep in mind, for the case where B was acute, we found that angle B was 34.2 degrees. So we're going to use that information because we know now this angle B has to equal, is the supplement of this angle B from the other solution of the ambiguous case. So this angle B has to be 180 minus 34.2. And if you guys do that, what do we get? We get 145. 145, oh, what does this come out to? 145.8, right, degrees. 145.8 degrees. So now we know B is 145.8. Okay, well now we can find angle A. So angle A will equal 180 minus 22 minus 145.8. And that will equal 12 degrees. Actually, it's going to be 12.2 degrees. It should be 12.2 degrees. And then, a bit of a stomach ache right now, but it'll go away. And then we can finally, the only thing we have left to solve for is side A. So side A, we can use the law of sines to solve side A. A over sine of A. Now we know angle A is 12.2 degrees, okay, equals, angle equals C, which is 20, over sine of 22 degrees, okay. Now we solve this for A. A equals 20 times sine of 12.2 degrees divided by sine of 22 degrees. And this comes out to 39. 39, okay. So now we know A equals 39. Now, does that seem right? That actually doesn't seem right to me. Something happened here that I'm not understanding. Let me just check this answer. It looks like it's a little bit off. 12.2 sine times 20 equals that, 1 over x. 1 over x, so up top is 4.22. I think something happened here, times 4.22. My apologies, this is wrong. I don't know, I had it written incorrectly in my notes here. I don't know how I got that. A comes out to 11.3. Excuse me, 11.3. That was this little calculation error. And if you saw, I caught my error. So erase this. This is 11.3. I caught my error because I realized that didn't make sense for our diagram because A has to be shorter than B. So that's a good case of making, maybe I'm glad I did that. A little embarrassed, but I'm glad I did it because it shows you guys the importance of checking your answers and the reasonableness of your answers. That didn't make sense. It forced me to go back and check the calculation, and I'd made some kind of calculation error. Okay, so this is our answer. A is 11.3. These answers seem fairly reasonable given our diagram, and now we've solved this case. So this was an example problem where we actually kind of encountered each different type of case you could have for an SSA triangle. And this concludes part 2 of our video lecture, and I'll see you guys on Tuesday.